Volt is standing over a map of open ocean when the radar blip in front of him just stops moving. Somewhere over that ocean right now, there's a plane that air traffic control cannot actually see. Not a conspiracy, not a glitch, just physics. Most people assume every aircraft in the sky is being tracked every second on some screen by someone. That's not true. It's never been true. And once you understand why, one of the most famous disappearances in modern history stops feeling impossible and starts feeling almost inevitable. Radar seems like magic, but it's really just geometry. A ground station sending out a radio wave that bounces off a plane and comes straight back. Simple in theory. Except radio waves travel in perfectly straight lines while the Earth itself is curved, and that one basic fact is where the whole problem begins. Once a plane flies far enough out over open water, it drops below the horizon from the radar station's point of view, the same way a ship slips out of sight as it sails away from shore. The signal doesn't fail. It just has nothing left to bounce off of. That happens closer than you'd think. Somewhere around 200 nautical miles from the coastline, radar coverage simply runs out. Beyond that line, there is no ground-based system watching the plane at all. Volt stares at the map. That's most of the ocean. Pilots talk to controllers over radio instead, calling in their position at set waypoints. The same basic method used since the earliest days of transoceanic flight. In the busiest corridors, satellite updates now close some of that gap. But across enormous stretches of the Pacific and Indian Oceans, that coverage still doesn't fully exist. If a plane goes quiet out there, there is genuinely no independent way to know where it is. Most of the time, none of this matters. Every flight checks in, radios back in range near the coast, and nobody ever has to think about the gap at all. But on March the 8th, 2014, that gap swallowed a Boeing 777 with 239 people on board. Malaysia Airlines Flight 370 left Kuala Lumpur just after midnight, bound for Beijing. 38 minutes in, a calm voice from the cockpit signed off with the last words anyone would ever hear from it. Good night, Malaysian 370. 2 minutes later, the plane's transponder went dark. A transponder is what makes a plane visible and identifiable on civilian radar. Without it, an aircraft becomes an anonymous blip, no name, no flight number, no altitude confirmed. This transponder didn't fail on its own. Investigators later confirmed it had to be manually switched off from inside the cockpit. Here's where it stops making sense. The plane went dark almost exactly where Malaysian air traffic control was due to hand the flight to Vietnam. A seam between two countries' airspace, where each side can quietly assume the other has it covered. Whether by knowledge or pure chance, this was close to the single best location on the entire route to disappear, with the least chance of anyone immediately noticing. For the next hour, the plane wasn't fully invisible. Malaysian military radar, built for defense rather than civilian traffic, kept picking up a return that matched. It showed the aircraft turning sharply off its route, swinging back across the peninsula, heading out over the Strait of Malacca. Then, at roughly 2:14 in the morning, that signal disappeared too. No radar on Earth held a confirmed sighting of the plane again. You'd think that's where it ends. Silence. Forever. It doesn't. Volt doesn't move. He's still waiting for the part that explains it. Deep inside the aircraft sat a piece of equipment nobody on board could see or switch off. A satellite communication terminal. Even with the transponder dead, it kept quietly reaching out to a satellite overhead once an hour in an automatic handshake carrying no location data at all. Just a signal, checking whether the connection was still alive. Volt leans closer. Nobody had ever needed to study these before. Now they were the only trace left behind. Investigators pulled the timing and frequency of every handshake and reconstructed motion from a signal never designed to reveal position. The final complete handshake came at 8:19 that morning, nearly 7.5 hours after takeoff, almost 2 hours after the flight should have landed in Beijing. That single detail changed everything. The plane hadn't crashed shortly after going dark, the way early searchers assumed. It had kept flying for hours, far past where anyone was looking. There was more hidden in that faint signal than just timing. As a plane moves relative to a satellite, the frequency of its signal shifts slightly, the same effect that makes a siren sound different as an ambulance passes you. Engineers used that tiny shift, buried in 7 hours of otherwise meaningless pings, to work out roughly how fast and in which direction the aircraft had been traveling. Nobody had ever needed to use the technique this way before. It had never been tested against a real disappearance at this scale. The analysis pointed to a vast, remote stretch of the southern Indian Ocean, thousands of kilometers from where the search had first begun, in water so far from anywhere that almost nothing about it had ever needed to be mapped in detail before. Search teams shifted almost entirely, scanning an area so enormous it briefly stood as the largest search operation in aviation history, larger than most countries on Earth. Ships, aircraft, and underwater drones combed water so deep, sunlight never reaches the bottom, mapping terrain nobody had ever charted in that kind of detail before, just to rule out square kilometer after square kilometer of open ocean. 16 months later, a single piece of wreckage, a wing part called a flaperon, washed ashore on Reunion Island, thousands of kilometers away. Confirmed as belonging to the missing aircraft, one of the only physical traces ever recovered. To this day, the main wreckage has never been found. Here's the part that should genuinely unsettle you. This wasn't an ancient aircraft with outdated equipment. This happened in 2014, in an age when almost everyone on Earth carries a phone that can be located within a few meters, almost anywhere on the planet. And yet a 63-meter aircraft, carrying 239 people, disappeared for over a week before anyone could confidently say which ocean it might be in. The uncomfortable truth is that this wasn't really a failure of technology. Satellites capable of tracking planes in real time already existed. It was a failure of decisions, built up over decades, about who should pay for that coverage and how urgently it was really needed, right up until the moment it clearly was. Volt already knows what's coming next. The cost was never the hard part. The will was. Fitting every aircraft on Earth with continuous satellite tracking costs real money, spread across tens of thousands of flights daily, and airlines already run on razor-thin margins. For decades, upgrading a system that technically worked most of the time never became urgent enough to justify the expense. It took losing an entire aircraft in plain sight of modern technology to finally make the case impossible to ignore. In the years since, the industry has quietly closed part of that gap. New international rules now require aircraft to report their position at least every 15 minutes, everywhere on Earth, specifically because of what happened that night. But even now, that isn't full, continuous second-by-second coverage across the whole planet. It's an improvement, not a solution. More than a decade later, the families of the 239 people on board are still waiting. No wreckage large enough to explain what happened. No final confirmation of exactly where, or exactly why. Just an arc on a map, drawn from handshakes never designed to answer a question this big. Volt looks up from the map one last time. So the next time you're on a long flight, and you glance up at the little screen showing your plane crawling across a wide, empty stretch of blue ocean, you'll know what's actually happening behind that image. For a significant part of that flight, you are, quite literally, out of sight. Not because anyone is being careless, not because the system is broken. Because the ocean is enormous, the Earth is curved, and for most of history, nobody built it any other way.